Hello everyone, welcome to Unacademy's dedicated YouTube channel for general aptitude, general science as well as engineering mathematics, the Unacademy Ascend. So we are again back with our daily practice problems or the daily practice sessions, and today we will be moving on forward to the third part of the pipes and cisterns, which comes under the general aptitude or under the quantitative aptitude section. So in the previous two sessions we did the part 1 and part 2. So today we'll be moving forward with the part 3. We'll be seeing another three questions of the same types, that is difficult, moderate and easy types. So let's not waste much of the time. Let's move on to the first question, right? So the first question is as follows: an empty tank can be filled in 90 minutes by water flowing from a pipe of square cross section of side 8 centimeters at the rate of 12 centimeters per second. Now, another pipe of a circular cross section is added at the bottom of the tank, which empties the tank at the rate of 16 centimeter per second. When both the pipes are present, the tank, when empty, gets filled completely in 240 minutes. What is the radius of the circular pipe at the bottom of the tank? Right? So this is where the question is. An empty tank is there. This can be filled in just 90 minutes by a pipe which is having a square cross section, and the sides are of 8 centimeter, and the rate of flow of this pipe is 12 centimeter per second. There is another pipe which is having a circular cross section. This is added to the bottom of the tank. Okay, this is added to the bottom of the tank. The tank is one itself. There are two pipes added to it: one pipe of square cross section, one pipe of circular cross section. This bottom of the tank, which pipe is added, the circular cross section, this also empties the tank. So this square cross section, it fills the tank, right? Square cross section fills the tank. The circular cross section empties the tank at the rate of 16 centimeter per second. When both the pipes are present in the tank, when both the pipes are present at the tank, when it is empty, right? When the tank is empty, both the pipes are present in it, and it gets filled completely in 240 minutes. When it is empty, when both the pipes are present, the tank gets filled completely in 240 minutes. So if it is getting filled completely in 240 minutes, what is the radius of the circular pipe, right? What is the radius of the pipe which is of circular cross section and which is basically emptying the tank, right? You have four options here. So let's move on to the answer, right? So I will start giving the solution here. So many mechanical engineers might know this formula, that is volume of flow of a pipe, right? Volume of flow of pipe, it is equal to rate of flow into area of cross section, right? It is equal to rate of flow into area of cross section. Yes or no? So if I take the first pipe, in the first pipe, what is a cross section, right? The cross section is a square, right? The cross section is square. Yes or no? The square, it is a square cross section. You know the side and you know the rate. The rate of flow is 12, right? What is the area of a square? It is side square. Yes or no? Side square. What is the side? It is 8 centimeter. So this will be rate of flow is 12 centimeter per second into 8 square, right? So this will be basically 12 into 64, which is 768, right? 768 units. Okay, 768 units will be the first pipe. Okay, now moving forward to the second pipe. What is the second pipe? Second pipe is a circular cross section, right? Second pipe is a circular cross section. And one thing we know, that there is a single tank. There is a single tank. So you are adding both these pipes, right? There is a single tank and you are adding both these pipes. So the volume of flow which is added, it has to be subtracted, right? So if you see the square pipe is adding, it is a filling up the tank. The circular pipe is emptying. So whatever the volume the square pipe is bringing, that volume that volume has to be subtracted by the circular pipe, right? Circular pipe. So the total volume here by the square pipe, 768 units, minus the volume of flow of pipe of 2, right? Minus the volume of flow of pipe 2. What is the volume of flow of pipe 2? What is the area of cross section? When you go into a circle, the area is given by pi r square. And what is the rate of flow? The rate of flow is 16 centimeter per second, right? Into 16. So this I can write it as 768 minus 16 pi r square, right? 768 minus 16 pi r square. So I got this. When in mechanical engineers, most of these people might know, right? In a pipe flow, the I will write down the statement here. The ratio of times taken together is equal to the that is equal to the inverse ratios, right? Is equal to the inverse ratios of volume per second, right? So this is what the statement is when you go into the pipes and cisterns. The ratio of times taken together is equal to the inverse ratios of volume per second. What is the volume per second ratios you have? This is the first pipe, which is 768 units. This is the second pipe, which is 116 pi r square. 768 minus 16 pi r square. If you go back, the filling pipe is taking 90 minutes and the total is 240 minutes, right? The filling pipe is 90 minutes. It can be filled in 90 minutes, okay? So the tank is already empty and it gets filled completely in 240 minutes. It is already empty. Empty से fill हो रहा है. Empty से fill हो रहा है. So 90 divided by 240. Yes or no? What is the ratio of times here? Ratio of times are 90 divided by 240 is equal to inverse ratios बोला है. So if I'm taking 1 is to 2, the next part is to be 2 is to 1, right? The next part is to be 2 is to 1. 2 is to 1. So this is 768 minus 16 pi r square divided by 768. So you have to cross multiply here. 90 into 768 is 69,120, right? 768 into 768 into 240 is 184320 minus 16 into 240 is 3840 pi r square. This is in the negative sign, so let's put it this side. So it is a 3840 pi r square is equal to 184320 minus 69,120. So this will be equal to 115200. So pi r square is 115200 divided by 3840, which is nothing but equal to 30. So r will be, right, 30 divided by 22.7. So r will be square root of 9.54, right? Here you have r square. So r will be square root of 9.54, which will come down to around 3.091 centimeters, which is approximately equal to 3.1 centimeters. 3.091 centimeters, okay? It is looking like kilometer, but 091 centimeter, which is approximately 3.1 centimeter, right? 3.1 centimeter. Go back to the options. It is option A, right? What are we doing here? We know the ratio of times. We are just finding out the volume of flow of both of them. 768 minus 16 pi r square. Equate both of them and find out the answer. The calculation is a bit more here, but the part to solve is very easy, right? The part to solve is very easy. So let's move on to the next question. A cistern has a leak which can empty it in 2 hours. A pipe which admits 25 liters of water per hour into the cistern is turned on, and now the cistern gets emptied in 3 hours. What is the capacity of the cistern? Right? A cistern has a leak which can empty it in 2 hours, right? 2 hours a cistern has a leak which can empty the whole contents in just 2 hours. A pipe is admitting, that is, it is filling up water around 25 liters of water per hour, and at this point of time, the cistern is turned on. Now the cistern gets emptied in 3 hours. So, what was the capacity of the cistern? It can basically empty in 2 hours, but when 25 liters of water is admitted, it is emptying in 3 hours. So, what is the capacity of the cistern? Four options are there. So, this is a quite easy answer, right? Quite easy answer. So rate of rate of cistern per hour, right? Per hour, sorry, I wrote it as her, right? Per hour, right? So when the inlet pipe is closed, right? When inlet is closed, okay? That is when water is not admitted, right? When in water is not admitted, it is x by 2, right? It is x by 2, right? The same rate of pipe per hour when inlet is closed. right? When the inlet is open, right? When inlet is closed, it is x by 2. When 25 liters of water is admitted, this becomes x by 3. X is the rate we have to find out, by 2, 2 hours time दिया है, तो हमें ये x find out करना है, x divided by 3, right? What is the total liters they have mentioned, right? They have mentioned it as 25 liters, right? 25 liters. So this is easy. X divided by 2 minus 25 is equal to x divided by 3, right? X divided by 2 when the inlet is closed minus 25, that is the amount it is added, you will get the whole tank will get emptied in x by 3, right? So x by 2 is the capacity. When it gets emptied, 25 liters are admitted. So after this phenomenon happens, within x by 3 times the whole tank will be emptied, right? Whole tank will be emptied. So take down the LCM here. So this will be x minus 25 into 2, 50, is equal to x bar 3. So I'll write it on here only. 3x minus 150, 3 into 50, 150, is equal to 2x. Take 2x this side, 150 this side. So this will be x is equal to 150 liters. This will be x is equal to 150 liters. A quite easy sum. A quite easy sum. Let's move on to the last sum of the class, right? A cistern can be filled by two pipes x and y in 65 minutes and 85 minutes respectively, and this same can be emptied by a third pipe in 45 minutes. If all the taps are turned on at the same moment, what part of the system will remain unfilled at the end of 175 minutes? A system has basically three pipes, and the two pipes are used for filling it up, right? Two pipes x and y are used for filling up the system, and it is done in 65 minutes and 85 minutes respectively. There is a third pipe z which can empty the whole contents of the tank in just 45 minutes. All the taps are turned on, मतलब सब taps को एक ही moment पर on कर दिया है, right? So what part of the system will remain unfilled at the end of 175 minutes? मतलब 175 minutes खत्म होने के बाद वो पूरा टैंक का कौन सा पार्ट अनफिल्ड रहेगा, मतलब पूरा टैंक का कौन सा पार्ट खाली रहेगा, कौन सा पार्ट फुल रहेगा, कौन सा पार्ट फुल रहेगा वो हमें फाइंड आउट करना है, उसको टोटल टैंक से माइनस करना है, और रिमेन अनफिल्ड एट द एंड ऑफ 175 मिनट्स क्या होता है, वो पार्ट क्या है, वो हमें फाइंड आउट करना है, राइट? सो दिस इज गोइंग टू बी अ बिट बिट ट्रिकियर क्वेश्चन. सो लेट्स solve this solution, right? So what are the things given to us, three times given to us? 65, 85 and 45, right? These are of three different types, x y z. So 65, 85 and 45, and z is a tank which is emptying, these both tank are positive which are adding, right? So at first thing what we will do is we will find out the LCM of 65, 85 and 45, right? 65, 85 and 45, so you will get it, this will get divided by 2, but later you'll get 5 13s are 65, 5 17s are 85. So 5 into 17 into 18, and 5 9s are 45, so it is 3 into 3, right? 5 into 17 into 18 into 3 into 3, you will get it as 9945, right? So assume this, right? Assume this as the total capacity, right? Assume this as the total capacity. So this will be 9945 liters, right? This will be 9945 liters. Let the capacity be 9945 liters. So what will be the rate of x here, right? Rate of x will be total divided by the time, right? 65, right? Similarly, what will be the rate of y here? This will also be the total 9945 liters divided by time, 85, right? What will be the rate of z? This is all per hours, right? So this is all per minutes because they have given this in minutes, right? 65 minutes, 85 minutes and 45 minutes. So we are taking this as per minute, right? We are taking this as per minute. अगर आपको per hour करना है तो minutes को hour से convert करके per hour कर सकते हो. इधर minutes दिया है तो per minute ही ले रहे हैं, right? Rate of z per minute is 9945 divided by 45. 9945 divided by 65 will give you the answer 153 liters. 9945 divided by 85 will give you the answer 117 liters. 9945 divided by 45 will give you the answer 221 liters, right? What is x? X is filling it up, y is filling it up, z is negative, right? Z is what? Z is actually emptying the tank. So how much part has been filled in a minute, right? How much part has been filled in a minute? So that is 153 plus 117 minus 221, right? 153 plus 117 minus 221, 270 minus 221, which is 49 liters per minute, right? 49 liters per minute. How much part has been filled in a minute? It is 153 x plus y minus z, because z is emptying, so we are taking it as 153 plus 117 minus 221, 49 liters per minute, right? 49 liters per minute. What is the total capacity? 9945 liters, right? The total capacity is 9945 liters. The time required for per minute is 49 liters per minute. So what will be the total time now, right? What will be the total time now? Total time will be 9945, that is the total capacity of the tank, divided by the time it requires to fill up, the time it requires to fill up a portion of quantity in a minute, right? A portion of quantity in a minute, which is 49 liters per minute. So 9945 divided by 49, 9945 divided by 49, you'll get the answer as 202.95. This is per minute, so we are taking this as minutes itself, right? Per minute, न्यूमरेटर में डिनोमिनेटर पर चला जाएगा तो मिनट्स हो जाएगा. So let us approximate this as 203 minutes. आप लोग 202.95 भी ले सकते हो या 203 भी ले सकते हो, डेसिमल का डिफरेंस होगा, but that is not going to affect your answer, right? So here, for filling up 9945 liters of water, this is taking 203 minutes, right? For filling up 9945 liters of water, this is taking 203 minutes. What is the number of minutes they have asked? At the end of 175 minutes, right? At the end of 203 minutes, the whole tank will be filled, right? So at the end of 175 minutes, how much tank will be filled? That will be X. So X is equal to 9945 into 175 divided by 203. 9945 into 175 divided by 203. So you will get this as 8573.27 liters. That is at the end of X, right? At the end of 175 minutes, this tank would have filled up 8573.27 liters, approximately 8573 liters, right? Approximately 8573 liters. So what is the percentage difference here, right? What is the percentage difference? Percentage difference को हम कैसे find out करेंगे? Total, right? Total is 9945. How much is filled? How much is filled? How much is filled? It is 8573 liters, right? तो हम कैसे find out करेंगे? What is the portion which has already been filled? It is 8573 divided by 9945, which is approximately equal to 0.86, right? Which is approximately equal to 0.86. मतलब 86% of the tank is filled, right? 86% of the tank is filled. So how much percent of tank is unfilled, they have asked, right? Will remain unfilled, right? Will remain unfilled. So what will we do here? 1 minus 0.86, which is 14%, right? 1 minus 0.86, that is 0.14, that is 14% of the tank is remained unfilled, 18% of the tank is already filled. You can use the same division method also, उल्टा भी कर सकते हो, 0.14 मिलेगा, same answer लिख दो, the 0.86, 1 minus 0.86, which is 14%. 1 minus 0.86, which is 14%, which is nothing but our option D. So that was a trickier question there, right? That was a trickier question. तीनों को rate लिया, प्लस प्लस माइनस किया, बाद में टोटल डिवाइडेड बाय पर मिनट, देन यू फाउंड आउट बाय द अप्रोक्सीमेशन मेथड और द क्रॉस मल्टीप्लिकेशन मेथड. So that was it. The end of the class, guys. So this finishes our pipes and cisterns topic in the daily practice sessions. So in the next session, I'll be bringing up a new aptitude topic, a new topic which is a part of our quantitative aptitude, and also which will be asked in most of the competitive exams, that is GATE and ESE. So please do wait for my next daily practice session, which will happen every alternate days. And don't forget to like and share the video, and also do subscribe to our channel Unacademy Ascend. Thank you. I will see you all in the next session. Have a good day.